Welcome back. Welcome back to Introduction to Speech Understanding. So let's go back to the GitHub page and see where we are. Let's see. I think that we're beginning lecture three today, and we can look at lecture three notebook on the GitHub page. But now that we've downloaded it to our computer, we don't actually need to go to the GitHub page. We should be able to see it um, on my own computer. So rather than opening it on the GitHub page, let me go ahead and open it on my own computer. I will open a terminal like this. On my computer, this is just the terminal command. So I could close the terminal, and then since I'm on a Macintosh, I would type Spotlight Search and type terminal. If you're on a Windows machine, normally you would open either normally there's a something called terminal, or you can also um, open what is it, the power window. And let me just increase the font a little bit. All I need to do anywhere above the directory where I have the course is to type Jupyter Notebook. So you can see I'm typing Jupyter Notebook. Since you installed Anaconda last time, or if you already had it on your computer, now if you just type Jupyter Notebook, it should start up the Jupyter program and allow you to open the lecture. Now you see that it's opened Jupyter Notebook showing all of the folders that are in my home directory. So we need to scroll down. Here's KCGI, Intro Speech Understanding, Lecture 3, and let's open the notebook. And now we see something that looks exactly the same as what's on GitHub, lists and loops, but we can test to make sure that this is that this is a real active notebook. For example, by inserting a code window here, you can see this says that this is code, and we can type print hello, and then press the arrow button, and it prints hello. So you can see that this particular Jupyter Notebook window is actually running on my own laptop, so I can test out Python code in this Jupyter Notebook. I can type 3 plus 4 and run it, and it prints 7, and so on. So good. We have a Jupyter Notebook that's editable, that's running in my own window. This week last week we learned about the basic data types in Python. We learned about integers and floating point numbers, and we learned about strings. And we also learned the if-else structure, our first syntax structure. We also learned about importing modules from another program, and that allowed us to import the homework2.py and edit homework2.py. We also learned how to define functions. So this week we're going to, that's all fine if you have a small number of things that you want to work on, but often you have many things that you want to work on. And so for that, you need a loop structure. Loop structures in Python work exactly the same way that they do in any other language. There's basically two kinds of loops. There's the while loop, which keeps going until some condition is met. And there's the for loop, which is a special case of the while loop that runs for a certain number of iterations. The for loop has an interesting generalization in Python that it doesn't have in other languages. So we'll talk about that when we get to it. Conditional execution is something that's kind of like a for loop, but it operates inside of an if statement. So we'll talk about code that is implemented only if you type the if and the elif and the else. Along with this loop, let's talk about containers that contain long lists of numbers. And there's two standard ways to list out data in Python. One is called the list, and one is called the tuple. And they're actually exactly the same. A tuple and a list look exactly the same, except that the tuple is not editable. Once you create a tuple, you cannot edit it. Whereas a list, you can create the list and then you can edit it to change some of its elements. Um, and then with those two ideas, the loop syntax and then the list and tuple, which are the looping data types, will all be all that we need in order to do the homework. So let's get started on that. For loops and conditional execution, let's start out with conditional execution. I told you last week about the if statement. There is no case statement in Python the way there is in C++ or C sharp. Instead, you use a sequence of if-elif statements. So if x is greater than 10, print x is greater than 10. Elif means else. So if x is not greater than 10, then else if it's greater than 4, print x is greater than 4. Else, if it's greater than 0, print x is greater than 0, and so on, all the way down to the very last else statement, which is activated only if none of the other conditions are true. I'm sorry, I have a bit of a cold this week, so I may cough sometimes. I'll try to silence the microphone when that happens. So let's go ahead and run that. Let's set x equal to 6 and run this code. And it says x equals 6, x is greater than 4. Now let's make it less than 4. Let's make it minus 2. If x is minus 2, it's not greater than 0, but it is greater than minus 6. And notice that this line, this is always activated, got printed both times. That's because the line, this is always activated, has white space, indentation, which is not inside the loop. So this print statement is inside the conditional, it's inside the if statement, but this print statement is outside, and so it gets activated. If I make it x is minus 20, then that's less than minus 6. And so the else statement is activated because x is no longer greater than minus 6. X is now finally less than minus 6. And so we print these two statements that are only printed if x is less than minus 6. Unlike most other languages, unlike most other programming languages, in Python, whitespace matters. The if statement here ends with a colon and then a new line. So there's a new line here that ends the if, and then exactly four spaces or one tab character before the beginning of the print statement, right? The elif, the block of the elif is exactly four spaces indented or just a tab character, and so on. The block of the else statement are these two lines, both of which are indented exactly four spaces. So unlike most other programming languages, white space matters in Python. So consider the difference between the following two code blocks. In this code block, we have if 4 is greater than 5, then print 4 is greater than 5. Print is this line part of the if statement. And then after we're outside of the if statement, print this line is definitely not part of the if statement. Or if we wanted this line to not be part of the if statement, we could move it outside of the if statement. So in this case, we print this line is definitely not part of the if statement. In this case, we print, is this line part of the if statement? This line is definitely not part of the if statement. So this line gets printed in this case, but does not get printed in this case, because in the above case, this line is inside of the if statement, and the if statement is false. 4 is not greater than 5. So white space matters. White space is how you determine which lines are inside of the if statement and which lines are outside. All right, now that we have that established, let's talk about loops. Most data structures that you work with in the real world are very long. Most of the time, you'll have lots and lots of data to work with. And so when you have lots of data to work with, you don't want to write a line of code for every item of data, because then your code will also be huge. You would like your code to be as small as possible in order to deal with lots of data. And there's essentially two kinds of loops, while loops and for loops. While loops are simpler. While loops are sort of the basic kind of loop. We start out with x equal to 14, and then while x is greater than 6, we print x, and then we subtract 2 from x. And so we run this and we see x is printed at, let me print um, now x equals, and then x. You can see now x equals 14, 12, 10, 8. The loop ended, and now x equals 6. So x inside the loop, x was equal to 14, 12, 10, and 8. And when 8 when x dropped to 6, it's no longer greater than 6, and so the loop ends, and now x is equal to 6. X continues to have a value outside the loop, and its value is whatever it was set to the last time that the loop was run. Notice that if we switch the order of these two commands, if I decrement x first and then print the value of x, then inside the loop, this first case, now x equals 14, won't happen, right? Instead, I'm going to start out with x equals 12, and it will go 12, 10, 9, 8, 6, and then it will print finally that x is equal to 6. And then when x is equal to 6, the loop will not happen again. So now it prints x is 12, 10, 8, 6. And then at this point, x has been set to 6. We printed that out. And then it goes back to the beginning of the loop and sees that x is no longer greater than 6. And so it stops and goes to the end. All right. A for loop can be much simpler, but it can, in Python, it's been made general, so it can also be much more complicated. Here's the simple version. The simple version is we want x to take some range of values up to the number 3. And so we say for x in range 3, print x. And then it simply prints those three values, 0, 1, 2. First of all, in Python, everything is zero centered. And so rather than going 1, 2, 3, it goes 0, 1, 2. And so it starts out by print the first value of x is 0, and then 1, and then 2. And then when it reaches 3, the loop stops. It doesn't actually reach 3. It only goes up to 1 before the end of the loop, right? There are some other things. There's some other funny things going on behind the scenes. Range is actually a function in its own right. So let me try, instead of this, let me try um, print what is range 3? It is, and then let me print the value of range 3. And I think you'll see that it's a range object. Range 3 is a range object. It's a special kind of object in Python that specifies the range of numbers that starts at 0 and ends 3 items later, 0, 1, 2. And let's ask what type of object. And let's print its type. So range is a function that returns an object of type range. That's a special class in Python that's used, basically it's used in order to specify the range in for loops. It's not used many other places. But there's another hint here. Let's remind ourselves. Remind ourselves that its value is range of 0 to 3. So its value is the range object that's created here specifies the starting value, 0. And since it specifies the starting value, we can specify a different starting value if we want. We could specify a starting value that starts at the starting value of 2 and goes up to but not including 5. You might ask, does this start at 2 and go for 5 items, or does it start at 2 and go? It seems like it should start at 2 and go for 5 items, but that's not what happens. What happens instead is that it starts at 2 and goes up to but not including 5. So range 2 to 5 goes 2, 3, 4, and then stops before it gets to 5. So the key for loop in Python is just this. For x in range 3, print x, 0, 1, 2. But the range object is useful if you want to start at some value other than 0. You can do that. If you want to increment by some value other than 1, so we can print from 2 to 15 with an increment of 2. Let's start at 3 and go up to 15 with an increment of 2. We get 3, 5, 7, 9, 11, 13. So the third element here specifies the increment. And that increment can be negative. We can go from 14 down by steps of -1 until just before we get to 8. So it goes 14, 13, 12, 11, 10, 9, and then stops just before it gets to 8. So the third argument of the range function can specify the increment or decrement. The other fun thing about the for loop in Python is that it doesn't need to have this range. We don't need to say for n in the range from 3 to 15. We can say for c in the string a, b, c, d, e, f, g. So any container object, any data type that contains a sequence, including a string, can be used in place of the range function in a for loop. So we can say for C in A, B, C, D, E, F, G, print the next letter is, and we get, the next letter is all of those letters, A, B, C, D, E, F, G. Um, if I changed this to the word hello, then it should print HELLO, right? It goes through and just checks each of those letters one by one. Um, there's a lot of other things that are worth knowing about the for loop. One is that you can put one inside another. So we can say for each character in ABC, for each number in 0, 1, 2, print the character is C and the number is N. And we get the character is AAA, BBB, CCC. The integer is 0, 1, 2, 0, 1, 2, 0, 1, 2. Another thing that's worth knowing about loops in Python is that you can break out of them using the break command. The continue command skips the rest of the current iteration. The break command stops the loop. And the pass command does nothing at all. So here we can go for n in the range from 0 up through 9. We'll print out n. But rather than printing out all of the values, let's not print 3, 6, or 7. And so what happens is we print 0, 1, 2. We skip over 3 and go to 4. And then 5, and then we skip over 6 and 7 and print out 8 and 9. So this continue statement is useful if you basically don't know what else to do. You want to stop this particular iteration of the loop and go on to the next one. So that's called continuing the loop. Something that I use more frequently actually is this break command. Break actually stops the loop. When you see any integer that's equal to 3 or 6 or 7, you want to stop the loop at that point. And that's useful. We get 0, 1, 2, and then we stop the loop. The pass command is really not designed to be useful. So if n is equal to 3 or 6 or 7, when Python sees this command, it does nothing at all. And so we still get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It still prints out 3 and 6 and 7. The pass command does nothing at all. The reason for the pass command is because sometimes you'll create an if statement, but you won't be quite sure what you want to put in the if statement yet. And so mostly the pass command is used while you're writing code. As you're writing the code, you have a placeholder. It's basically just a placeholder to say, at this point in the code, I want something here, but I don't know what it is yet. And so you can put a pass command in order to do that placeholder. There's something else I want to cover that's not listed here, so let me just create it. I said that you can put C in hello, but you can also enumerate the elements of hello. And what that will do is provide a number for each of the characters. So we can say the next letter is C, and we can say which is letter number, and then we'll print the N. So this enumerate command is often very helpful in for loops. We have a string here, which is a sequence of characters. This string is a sequence of characters, and we want to know the number of each of those characters as well as the letter. And so we can use enumerate to tell us both the number and the letter of each of those characters. So H is number 0, E is number 1, L is number 2, L is number 2, and O is number 4. Right? So in this way, we can tell, we can get both the number and the character. And that's useful in many practical situations. All right. So that's the syntax that we use to deal with lots and lots of data. We want to create a loop in order to help us to work through lots and lots of data. The data types that we use to work with lots and lots of data, Python has many of them. This week, we're only going to look at the first two, and then next week and the week after, we'll look at additional data types. Next week, we'll learn about dictionaries. The week after that, we'll learn about arrays. Lists, tuples, dictionaries, and arrays are different ways in which Python can manage large quantities of data. So here's a list. The nice thing about a list is that it can contain any data type in any element. Here's a list that has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 elements. The first 3 elements are integers, the integers 1, 2, and 3. The next 2 elements are the strings, they're the string hello and the string world. And then the last 3 elements are Booleans. They're the value true, and the value false. Right? So we can print those out. We can create them and print them, and we see that list one is 1, 2, 3, hello world, true, true, false. Tuple one is 1, 2, 3, hello world, true, true, false. The only difference we can see so far is that a list has a square bracket and a tuple has a curved parenthesis. This is called in English a bracket, and this is called a parenthesis. They're different characters, although not all speakers of English use those terms precisely, but I will try to use them precisely because they are important. The distinction is important in Python. And so far, the only difference between a list and a tuple is that the list uses the bracket and the tuple uses the parenthesis. All right. And in fact, you can take a string and convert it to either a list or a tuple. So let me create the string. This is a string. And let me convert it to a list. And let me convert it also to a tuple. And let me let me find out the length of each of those. Let me find out the length of string 2. And let me find out the length of list 2. And let me find out also the length of tuple 2. So here's the list. This is a string, and the only difference we can see between the list and the tuple is that the list ends with a bracket and the tuple ends with a parenthesis. The length of the string is 16, the length of the list is 16, and the length of the tuple is 16. Let me just add them there. Right, now we can see, and its value is, here's the string, this is a string, and here it is as a list of characters. Notice that this includes the blank character. Right? The blank character was one of the characters in the original string. And so when we convert the string into a list of characters, that blank shows up as one of the characters. When we convert it into a tuple of characters, that blank is one of the characters in the tuple. We can also create an empty list or an empty tuple. Here's the empty list. It just is open bracket, close bracket. The empty tuple is open parenthesis, close parenthesis. And so we see that the list bracket, open bracket, close bracket has a length of 0. The tuple open parenthesis, close parenthesis has a length of 0. That can be useful because we can add elements to a list or a tuple. Before we talk about adding elements to a list, we can add elements. Before we talk about adding elements, let's first talk about how to access any particular individual element. So in list 1, I had the numbers 1, 2, 3, hello, world, true, true, and false. So the third element of this list is the word hello. The number three element of list one is, and the number three element of list of tuple one and we see that even though the third element is the number three element is the string hello. And that's because um, indexing in Python starts as zero. The number one is the zeroth element, is the element zero, and so on. So if we wanted to get back the number three, we would have to find the number two element. And that will give us the integer three, which is the third element of the list, which is element number two. If we want the first element of the list, we want the number zero element of the list. So Python starts its indexing at number zero. And in fact, even though the length of the list is 8, if we tried to ask for the number 8 element of the list, we would get an error because there is no number 8 element. List index is out of range. If we go and look, we see that there are 8 elements, and the last of those is element number 7. So if we want the very last element, we can ask for element number 7. Python has a special syntax for accessing the very last element. We can access it as the number minus one element. So we can ask for element number minus one, and that will return the very last element of the list. The list one of minus one is the very last element of list one. We can also get a series of elements, all of the elements starting at element number two, all the way up through, but not including element number five. So element number two is the three. Element number three is the word hello. Element number four is the word world. So we can list those as shown there. So in all of those ways, lists and tuples are exactly alike. The main difference between them is that we can change the elements of a list, but we cannot change the elements of a tuple. So I can change the element of the list, and now it's 1, 2, 3, hello, Kyoto, true, true, false. But if I try to do that to the tuple, I get an error. Tuples are not assignable. You can't change the element once it's been created. This is mostly for bookkeeping. It means that mostly it's good for debugging, right? Because a tuple can't be changed, you can specify your data type as a tuple, and then you know that it will never be changed. You know that the code later on will never be able to change any value of your tuple. Last time I showed you that you can concatenate strings by adding them together. And you can do the same thing with lists and tuples. We can take this list one and this list three, and we can add them together as shown here. Instead of calling them list one again, let me call them list two and tuple two, and then add those together in this way. So, and then you can also multiply them by four. List three times four is, and it will be repeated four times. Tuple three times two is, and it will be repeated two times. And so we can see that when we add them together, adding two lists is the same as concatenating them. Adding two tuples is the same as concatenating them. This is not changing the original tuple, by the way. The original tuple is unchanged. What I've done here is created a new tuple and just returned that. Let me show that to you by printing the original tuple. List 2 likewise is still unchanged. So you see that when I add them together here, I'm not changing the value of list 2 or tuple 2. Instead, I'm creating a new tuple, which is the sum of tuple 2 plus tuple 3. Multiplying them by an integer does the same thing that it does for a string. Pardon my cough. All right, this may be almost all that we need. Let's find out. I think we're close to the homework at this point. There's a lot of different things you can do with lists. I mentioned enumerate that can take all of the items of list one plus the doubled list three. So I can take list two plus doubled list three, and I can print out all of their elements together with the integer that indexes them. I can also create an element list two, and then I can add another element to it. And so this only works for a list because, right, I'm taking this list and I'm appending an element to it. I'm appending some other string at the end of it. Um, let's append the string again, and let's specify what its value is. All right, so we have hello world again has a length of 3, and its value is hello world again. Oh, I should say, um, yeah, I should actually put that inside the string. I should say list 2 has a length of 3, and its value is hello world again. If I append the word again again, then I'll get it appended twice. The append function, unlike the add function, actually changes the list. Right? I appended and I got hello world again, and then I get hello world again again. So this append function is actually changing the list by adding an extra word at the end, extra string at the end. If I do this again, then it will add it again, 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 3 times. I can also start out with an empty list, and I can print empty list. So you can see we have empty list starts out with a length of 0, and its value is open bracket, close bracket. And then when I add the elements B, C, I append the elements A, B, and C to it, now it has a value of A, B, C and a length of 3. So that append command is adding things to the empty list. This is the main utility of an empty list. The main utility of an empty list is that you can create a place where you want to store things, but you don't have the things that you want to store there yet. And so you define a list structure as a place where you can store those things, and then you start appending them afterward. You can also sort a list. We could take the sentence, hello, this is a sentence, and we can sort it alphabetically. The first word is A because A starts earlier. A is the first letter of the alphabet. H is the next word alphabetically. I is the next word alphabetically, and so on. So the sort command sorts it alphabetically. That also works with numbers. So if I create int list equals 3273 minus 1, 6, and then sort it, then it will be sorted in ascending value, minus 1, 2, 3, 3, 6, 7. So sorted in increasing order. And then we can also find out the length using the len function that tells us the length. All right, those are the basic list functions. Yeah, there's this wonderful syntax that puts together the for loop and the list, and this is called list comprehension. This is a special syntax that it's really mysterious if you've never used Python before, but it's really useful, right? And it's a very constrained syntax. You use it exactly as shown here. You use the open bracket to specify that you're beginning a list, and then you specify what each element of the list should look like. It should look like 2 times w, where the w here is a variable that you haven't defined yet. And that variable is defined by the for loop. Here, for example, I have for w in the range from 45 to 67 with a step size of 2, I want to double that value. So I'm taking a step size of 2, and then I'm going to double the values. So the smallest value will be 45 times 2, which is 90. The next smallest value will be 47 times 2, which is 94, and so on. Let's do just let's do just the range from 0 to 5. And we have the integers 0, 2, 4, 6, 8. Those are 2 times w for w in the range from 0 to 5. We can also do c times 2 for c in the string hello. And what that will do is that will go through every character in the string hello, and it will double that character. So we get HHEELLLLO, right? So we skip through it, one doubling each of the characters in the word hello. It can also include if statements, and this is kind of weird. It includes the if statement at the end. So we can go through the list hello 5, 7.5, 10, and include it, double it and include it only if w is an integer and not if it's a floating point number or a string. And so in this case, it keeps only two of those elements, the element 5 and the element 10, and it doubles both of them. This list comprehension syntax is not essential to, it's not essential ever, but it makes it possible to program a for loop using a much smaller syntax. And so it's often used by people who program in Python a lot. All right, as in previous weeks, the homework will be graded on GitHub. So open up homework3.py and let's find out what's inside it. Help on homework module homework 3. It looks like we have just one function in this homework. The function is words to characters that converts a list of words into a list of characters. So we start out with a list of words and we turn it into a list of characters. For example, if the list of words is hello 1.234 true, notice that 1.234 is not a string. It's a floating point number. True is not a string, it's a Boolean. And yet we're going to convert each of them into a string first, 1.234 as a string, true as a string, and then after that, divide it up into characters. Um, let's see. I think that the other things listed here are not used this week. We have the cancellation function and the copy all but skip word. Let's find out. Let's look at the homework. Yeah, the homework only has this words to characters function. So I'm sorry, the cancellation is listed here, but it's not actually in the homework. I think all we have to do in the homework is to take an input list of words and create a list of characters. So let's start out saying list of characters equals the empty list. And then let's go for every word in the list of words. We'll take for every character in, and we'll take that word and convert it into a string. So if the word is something like 1.234, we'll convert it into a string first. And then we will take list of characters. I prefer it with an S at the end. And we will append that character to the list. And then we'll just return our list of characters. Let's save that. And let's see. Um, I don't think I need any of these. Let me go down and find the grade. Let me run the grading program. Does it work? Grade is looking for homework two. This is a mistake. Let's see what the grading function looks like. Test words to characters. This is importing homework three. Oh, characters equals homework two dot. This should be homework three dot. There's an error in the grading function. So if you try to grade your own homework, you'll need to change this word from homework two to homework three. And once you change that word, the grading function should work. Let me try it and see if that happens. All right, now I got 100%. So you can see that the grading function that I've given you is only grading one function. It's only grading the words to characters function. So once you've got that function written, you should be able to check it into to GitHub, and I can grade the result. So let me go ahead and run GitHub Desktop. All right, so it looks like I've got homework two is changed, and in homework 3.py, I've changed, sorry, homework two has been changed to homework three. Homework three has all of these new lines that I've written, and the lecture three notebook has all of these things I've written. So let's say homework three. Um, I did homework three, and then let's commit that to the local repository and push it to the origin. And then we'll check to make sure that it actually showed up on my student GitHub account. Here's my student GitHub account. And let me go to lecture three and open homework. And there it is as I've written it. So now I should be able to take that URL, copy it, and go to homework three, and then just enter that URL here under homework3.py. That's all that you'll need to do for this week's homework. So please go ahead and work on that, and I will go through and grade those. Also, I have not yet graded homework two, but I'll go back and grade those now. That's all for this week. Let me stop the recording and then let me do attendance. So first, let me stop the recording.